Welcome to another of our videos. This one's on transmitters, part 3, dual rate and exponential. This is actually going to be split up into 3 videos, so make sure you know which one you're watching. First video is going to be over dual rate and exponential theory. We'll have some video illustrations, and we'll just teach you what dual rate and exponential are without any specific transmitter programming. Now that we've covered the dual rates, let's talk a little bit about exponential. I've cleared this graph here because I only want to talk about exponential. We'll cover how dual rates and exponential mix after this segment. With our transmitter stick movement here and our servo throw being graphed here, we use exponential to define a method so that it can numb the sticks, the transmitter stick, around its center point, changing the servo arm throw based on the location of where your transmitter stick is. So your typical exponential graph, if I were to graph this out, looks something like this. At 100%, we'll assume this is like a high rate where it's just it would be a linear line if I didn't have any exponential on. We'd start here at the corners, meaning as our transmitter stick is moved from center all the way to one end, the servo arm is moved all the way to its end point. And it looks like it's going to start to go towards that corner, but it actually takes a curve like that. So if you look at the endpoints, my transmitter stick, it looks like high rate endpoints. That when I'm at my corner point here, with my transmitter stick all the way to the one side, my servo arm is moved all the way to its maximum endpoint. Same thing with its first. If I have my transmitter stick moved to the opposite end, the servo arm is at its opposite end. However, this curve here changes how that servo throw works. At the center point, or around it, this area here, you can see that the servo throw isn't linear anymore, that it actually has a curve here, and that it's not moving as far as if my transmitter stick is over here. Then my servo throw is almost at an exponential curve. That's how they get the term exponential. If I were to look at this with a linear graph to show kind of how that differs, it would look something like this. Starting at this endpoint here, moving towards your center, and moving towards your opposite endpoint. I'm not the greatest line drawer, so please forgive me for the little crookedness and whatnot, but the idea remains the same. At center, for both an exponential and a dual rate, high rate, low rate setup, your sticks are at center, then your servo arms are at center. But your servo arm travel changes with an exponential curve compared to your linear one, but the endpoints still remain the same. So think of it as steering in your car. If you have really loose steering, you've got to turn the steering wheel a bit before you really feel it take hold and your car actually starts turning. That's more like exponential, or an exponential curve applied to your graph. If you don't have exponential curve, and it's just a high rate of 100% linear all the way from here to here, you've got really tight steering, that as soon as you start turning that wheel, your car responds and you start turning. So you can use that analogy to compare it and understand what exponential does for you. And the same for the dual rates, for the high rates and the low rates. For example, if you're on a high rate, that means that your steering wheel can turn all the way around to its maximum endpoint. But then if you were to set a low rate of 50%, you'd only be able to turn your steering wheel half as far as you could before. You can already start seeing where that might change how you would drive, how you would take turns, how you would be able to do tighter turns with a high rate, but less risky and tighter turns with a low rate. Same with the exponential and the tight and the loose steering. So when you combine these two graphs, what you kind of end up with is something that looks like this if I'm on a high rate, this curve, because this is 100%. If I'm on a low rate and I've got exponential, by the way, you're never supposed to do that to a dry erase board, but I am quite the rebel, so I did it. If I've got a low rate of 50%, that means my endpoint is here and here. So I'm going to have some type of curve like this. It's the same idea that applies. All we're doing with the low rate is just changing where our endpoints land. But with the exponential, we change and we give it that curve. So remember that our low rate used to look with a linear line, used to look like this. Wow, that's really crooked, but you get the idea. So our linear line used to look like this. And now with that curve, you can see that around the center point, around this kind of circle that extends out in a sense, your servo arm is not moving as far. Your stick is very numb at the center, but as you extend out, that catches up and your servo arm starts moving more like it did with the linear graph. With that in mind, let's go with the video. We'll compress my head again so you can see that I'm getting smaller. And we'll look at Expo a little bit. You'll see that I'm starting off right now with a basic high rate, no Expo, and 100% throw. So kind of very similar to how we started the first video. As I move the transmitter stick, I move all the way in a linear line from this point to this end point. As my transmitter stick moves from left to right, servo arm also moves from its maximum endpoint to its opposite endpoint. Okay, now magic hands flick the exponential, which is basically just another set in the dual rate setting. So I'm flicking from a high rate to a low rate. We'll say that the low rate is still 100% servo throw, but we'll have exponential on it, where with the high rate, it was 100% servo throw without exponential. So now exponential's turned on. Now I'm moving that stick, my transmitter stick, left and right, and now I'm actually following more of a curve. It may be a little difficult to see on the video because it's easier to see up close and in person, but you'll get the idea if you try it yourself by just changing that exponential, and if you set it to something very high, you can see it dramatically. You can really see how even moving the transmitter stick halfway out, it barely moves a servo arm, but as soon as you start reaching that maximum endpoint of your transmitter stick, that servo arm really catches up. Now that we've covered dual rates and exponential in video and graphic forms, let's ask ourselves why we might want to make changes to our transmitter. Well, first one might be training. If a craft is new, or if it's new to you or you're a beginning pilot, you might want a lower rate, preferably less than 100%, so that your craft flies in a more docile and subdued fashion. As a new pilot, you often have a tendency to jerk the transmitter stick real fast one way, without realizing it, and then your craft is performing a very tight turn. Then you have to jerk it the other way to compensate for that, and you're constantly in a battle of turn to turn or loops and whatnot. Well, with a low rate, that only remember that changes your servo arm throw, so it only moves half as far as your full throw. With a low rate, your control surfaces on your aircraft won't extend as far, and that means your flight will be more subdued. You won't jerk it off to the left and have it perform such a tight turn. You have to jerk it back off to the right to compensate. It'll still turn, but it won't turn as fast and loop as fast, so on and so forth. So if a craft is new to you and you want to just get a feel for it, have a low rate set up. Oftentimes, you'll find craft that you'll find in the store like the P-51D Micro Mustang Flyer. It's very recommended that as you first get a feel for the plane, you use its low rate, because at a high rate setting, it's an extremely twitchy and squirrely craft to fly. So for new pilots, or for pilots just getting used to that craft, a low rate is preferable until you get a feel for it, then you switch to a higher rate. With the programmable transmitters though, you can change exactly what rate for each of your servo channels you want, where with the stock transmitter, say for the one that comes with the P-51D Micro Mustang Flyer, you only have your option of a high and a low rate. Your other reason that you might want to have dual rates and exponential on your craft is speed. As your aircraft is moving faster, for example, I've got this foamy flyer here, and as this moves faster through the air, these control surfaces, if they deflect the same way if I'm moving very fast, they change the characteristics of the flight just by the craft moving faster through the air. So as this is moving faster, the same deflection as if I was moving slower will actually cause the plane to turn tighter or loop tighter than if it was moving slow. So if I'm going high speed, I might want a lower rate that I just change with a flick of the transmitter switch while I'm flying. And if I slow down, I might want to flick back to that high rate so I have some more control at the lower speeds. Those are your two primary reasons for having dual rates and exponential set up. Now, I really didn't cover why training and speed might affect for your exponential. Let's just say that if you're just starting to get a feel for a craft, that exponential numbs that stick, that transmitter stick around the center point. So that means that you also have a tendency not to overcompensate so much. Or as you're just learning to hover, it's great for hovering helicopters. As you're learning to hover a helicopter, having a lower rate with some exponential set up really allows that stick to be numb so that as you're learning just to get that hovering straight, that your stick movement doesn't jerk it and then you've got to once again play the compensation game, and it really lets you get a feel for that craft. So between dual rates and exponential, it's a really great way to change the characteristics of your flight in flight with just a flick of your transmitter. This covers the first part of our Transmitter Part 3 series on dual rates and exponential. The next 2 videos will cover the specifics of changing dual rate and exponential for both a helicopter and airplane with your DX6i and DX7 transmitter. I'm Eric R. Christoph of Hover and Smile. Thanks for watching.